I thought number 7 was kind of a good problem. Let's read the instructions from 2.1. It says, if A is equal to this and AB is equal to this, determine the first and second columns of B. And then they want us to let B1 be the first column of B and B2 be the second column of B. So we've got to find those little B's. So essentially B is this. Just remember the lowercase b's represent columns. They're not just numbers in this case. All right. And by the way, let me just say something about sizes. A times B. Well, A is a 2 by 2 clearly. And notice that AB is a 2 by 3. Okay. So that means B has got to be a 2 by 3. Because remember, when you multiply A and B together, those two numbers have to match up, but the product has got to be a 2 by 3. So that means B has got to be a 2 by 3 matrix. Okay, so that's how I knew I had 3 columns there. All right. Now I'm going to use kind of an important fact, and this was mentioned in problem number 6 more generally. And it basically says this, that if you multiply 2 matrices together, then this is true. As long as all the sizes are correct, A times B is the same thing as this. It's matrix A times the first column of B, and then matrix A times the second column of B, and then matrix A times the third column of B. All right, so these are column matrices. And let's just check and make sure the sizes are correct in this case. Once again, A is a 2 by 2. But what about these B's? Well, let's see. I've already decided that B is a 2 by 3. So that means each one of these columns is a 2 by 1. Okay? That's a little tricky. But let's see if the product exists. Well, A is a 2 by 2. And I would be multiplying that by a 2 by 1. So that looks right. I'd end up with a 2 by 1. So every one of these would be a 2 by 1. So is the size of this product the right size? I think it is, because that would give me a 2 by 3 for AB. But if you look at problem number 6, it basically says something like this in a little bit more generally. So this is the fact I'm supposed to use, okay? But just remember the lowercase b's are just the columns of matrix B. So let me use that fact. But remember, AB is given to us. AB is this. And that's supposed to be equal to this. Okay? So that means this is supposed to be equal to this is supposed to be equal to that, and so on. They really only want us to find a B1 and B2, though, so that we don't have to find B3, even though we probably could using the same technique. But I basically just have to force these two guys to be the same. And I might just do this for B1. You can do the B2 yourself. It's the same idea. But just kind of think of this as a variable. That's kind of like an X. So once again, we're just solving a system of equations, even though it doesn't really look like it at first. Finding B1 is really the same thing as solving this system, isn't it? So let's write down the augmented matrix for that system. Well, here's matrix A. And the right-hand sides of the equations are -2 and -3. So that's the augmented matrix for that system. So really, I just have to solve that system. All right, so let's put it in reduced echelon form. 4 times the first plus the second. That'd be -16 plus 5, which is -11, I think. 4 times that is -8 minus 3 is -11. Now divide the second one by -11. And then I guess multiply the second one by 4 and add it to the first one. This times 4 plus that is 2. Okay. So it looks like the solution is 2, 1. All right, so that's our B1. So B1 is 2, 1. And you can find B2 in a similar way. But I'll stop there. They didn't even ask us to find B3, but I'm sure you can do the B2 yourself.